So for this example, we want to use the addition method to solve x plus 2y equals 3 and 2x plus 4y equals 6. Which variable do you want to try to eliminate? X or y? X. So if we try to eliminate the x's, right now I have a positive 1x and a positive 2x. They could each be turned into 2 or negative 2, right? So do you want to multiply the top one by negative 2?
Yes.
Let's multiply the top by negative 2, and the bottom one could just be an understood 1. So that gives us negative 2x minus 4y equals negative 6. And the bottom stays 2x plus 4y equals positive 6. And here's where things start to go weird. What happens? Everything on both sides cancels. So we have 0 equals 0. Does that mean that they are parallel, or does that mean that they are actually the exact same line? They're the exact same line. So it's not that they have no solution, it's that they have infinitely many solutions. So infinitely many.
If there was 0 on one side and like negative 12 on the other,
Right. These have infinitely many solutions. So I need to teach you how to write this answer. Different books want you to write the answer different ways. So here's how your book wants you to write it. Now, if it's no solution, you just write no solution. But if it's infinitely many solutions, they want you to open up an ordered pair and just let the first one be x. Okay? And the second one be the equation in slope-intercept form. Y'all have any idea what I just said?
No.
Okay, if I solve either one of those equations for slope-intercept form, I'm going to get the same thing, right? So come up here and solve this for slope-intercept form. And we have 2y equals negative x plus 3, and divide everything by 2. So we have y equals negative x plus 3 over 2, or negative 1/2 x plus 3/2. That is how they want you to write the final answer. And that, it means this. Any x you want will make that true. Any x at all. You can pick it. But the y value has to fit this pattern in order for it to be a solution. So it has infinitely many solutions. And you can pick the x. But whatever the y is depends on what you let x equal. Okay, let's pause for a second and see if you guys have any other questions about that. For this next example, we have x plus y equals 3 and x plus y equals 2. Do you guys want to solve it by substitution or elimination? Elimination. So that means I need to multiply one or both of them by a number to make one of your variables opposites. So you pick a variable to work on. Let's say we want to get rid of the y's. Well, they're both already positive 1, so really I just need to multiply one of them by negative 1. And I'm going to multiply the bottom one by negative 1 and leave the top alone. So we'll pretend we multiplied it by positive 1. Then we have 1x plus 1y equals 3, and negative 1x minus 1y equals negative 2. And when we add those together, the left side completely cancels. All of our variables cancel, but our constants don't. They make positive 1. So it's not 0 equals 0, which would always be true. It's 0 equals positive 1, which is never true. And so if something is never true, that must mean that the two lines are they're parallel. Yeah. And parallel lines never have a point of intersection, so we just say that it's no solution. Or if you want to, you can use the empty set symbol. This, do you guys know that the name of this is the null set? Y'all ever heard that? You learn something new every day? For this next example, there is just way too much going on. So I recommend that before we do anything, let's just multiply through by the least common denominator on each and turn them all into integers. It's just going to be easier to deal with. So I can multiply the top equation through by 20. And let's see what we get. The 20 and the 4 reduce to 5. So I have 5 times x plus 2y plus the 20 and the 5 reduce to positive 4. And I have 4 times x minus y equals 20 divided by 4 divided by 5 is 4, and 4 times 6 is 24, right? Okay, so I still have to work on that a little bit more. If I work on that a little more, I have 5x plus 10y plus 4x minus 4y equals 24. So now we're looking at 9x plus 6y is equal to 24. I could stop there. I mean, it's easy to work with. It's 9x plus 6y equals 24. They're integers. But does anybody know something I could do to that equation?
Yeah.
I could reduce it all by 3. You can reduce equations. If you can reduce both sides, you can reduce them. So do you guys want to do that? Reduce it by 3?
Yeah.
Okay. So if we reduce it by 3, we're down to 3x plus 2y equals 8. So I'm going to kind of put a bubble around that to remind myself that's sort of what I'm working on. That's the first equation all cleaned up. 3x plus 2y equals 8.
Wait, why did you reduce it?
Because I could. You don't have to. We could stop at 9x plus 6y equals 24.
Where did the other numbers go?
I divided both sides by 3.
Oh.
You know how like in an equation you can multiply both sides by something? You can also divide both sides by something. So I just divided everything by 3. So I've cleaned up the first equation. Now I want to go through and work on the second equation. For the second equation, what can I multiply through by? 21. Multiply both sides by 21, and that will leave me with 3 multiplied by x plus y minus 7 multiplied by x minus y. And that has to equal negative 36. 21 times negative 12 over 7 is negative 36. All right, let's distribute. We have 3x plus 3y minus 7x plus 7y has to be equal to negative 36. And that tallies up to negative 4x plus 10y has to equal negative 36. And I could stop there, or I could do what at this point? Reduce them all by 2. Yeah, I could divide both sides by 2. Let's go ahead and do that. If I divide both sides by 2, I have negative 2x plus 5y equals negative 18. Okay. So after all of that work, I still haven't solved them. I have just gotten them ready to solve. So now we have to go up somewhere and solve them. So let's put them back together and take 3x plus 2y equals 8 and compare it to negative 2x plus 5y equals negative 18. You guys want to eliminate the x's? Because one's already positive and one's already negative? Yes? So let's multiply the top by 2 and the bottom by positive 3. And that gives us positive 6x plus 4y has to equal 16. And negative 6x plus 15y must equal negative
54. No. Wait. Was I wrong?
negative 54. No, you're right. Okay. Then we add them together, and we know that 19y equals what? Negative 38. 16 plus negative 54 is negative 38. So it looks like the y value is negative 2. There's one of my answers. How do I find the x to go with it? Do you want to go back to the original?
Yeah.
I don't want to go back to the original. I want to go back to one of these. Does it matter which? No? So let's go back to this one right here. If I plug negative 2 in there, I have 3x plus 2 times y, which would be what? Negative 2 has to equal 8. So that would be 3x minus 4 equals 8. 3x equals 12, and x equals positive 4. So the solution to this system of equations is the ordered pair 4 comma negative 2. And we should plug that back in, the very original, to check to see if it makes both of them true. But we're running low on time, so we're not going to take the time to do that.